Alright, hell yeah. 10 minutes on the clock, and this is a math video. And these math videos just make me so manic. But anyway, we're going to try to solve this, you know what I mean, my way. And I've already kind of done, you know, enough notes on this yesterday, so we're not just hitting it from scratch. It's not going to be a 3-hour video. But what we got, you know what I mean? Hey, look at this. This says X right here. So let's just go over here, and what's the X graph? This is a graph of y equals x. I think this is the first graph we ever know. And then the second graph that we know is x squared. You know what I mean? Kind of looks like that. Well, look at that. It looks kind of like x. Y is equal to x. And I think we should throw in here, you know what I mean, the solid contender of like, whoa, this looks like x squared. Oh, well, what'd you do there? What'd you do there? Well, this is x cubed. You know what I mean? It's just a mirror image in the negative region, you know what I mean? Because if you take a negative, negative times a negative, well, hell yeah, that's a positive. But then times another negative. So if you start with a negative number, you're going to end with a negative number. Start with, yep. So if you just start with any negative number and throw it in here, you're going to take that negative number 3 times. Compared to here, if you take a negative number, you're going to take that negative number times the negative number. It's always going to be positive. So, yep. Okay, anyway, I think we get it. What's x to the 4th? You know what I mean? That's where our brains just go, you know, just we don't know. But it's just steeper. But two things happen. And one I don't even know how to explain. But this x to the 18 is like, well, it's hella steep. But then once you come down here, it's just like, it's almost like a square. So we need to figure out where that square happens. I mean, because look at it, like this is just 1 right down here, and this is probably 1 right here. So I think all that square stuff happens. So here's like 1, 1, and then over here x squared. Yeah, 1 squared is just 1. So we go to 1 and we get 1. X to the 18, that's the first one we're going to do. X to the 18. 1 to the 18, well, guess what? That's just 1. So if we're over here at 1, we're going to be right here at 1. But this thing just goes up to like infinity real fast, or even just 10 million, trillion, billion. Got it. Okay, now, do we know anything about this? A number to another number. You know what I mean? This essentially is like this. A number to the x, you know what I mean? A constant to the x, where this is an x to a constant, and you know, if we're gonna throw in just a number, like this could either be, the other one this could be is x to the 0, x to the 0. All right, and that's just 1. That's just a line. So there you go. X to the 1, x to the 2, x to the 3. And then it just goes back and forth, because x to the 5 is just hella steeper x to the 3. X to the 17 is just hella steeper. X to, and is that right? You know what I mean? Let's just throw in x to the 17. And we're just kind of, whoa. Got to crash the calculator. Zoom 6, just zoom normal. Hell yeah. So yeah, it's just real boxy. You know what I mean? And just so we're all on the same page, you know what I mean? And yep. Okay, so now let's learn something about this, because if we you know, okay, so the first thing to do is just maybe throw in this one. We already kind of knew how the whole graph worked. You know what I mean? The whole line. We could actually draw the whole line just from, you know, math class. Where this one, hell no, we can't draw the whole line. We can't just be like, oh, I know what's going on here. No one knows what's going on here. Because even this one, let's say you throw in -1. You know what I mean? Well, yeah, it sounds like it's just over there. You know what I mean? If you have x squared and you throw in -1, hell yeah, -1 is just over here. You have this, no one knows. You throw in -1 right here, no one has a friggin' clue. So this one we don't know, we don't have like just an abstract view or an actual view of what the heck the graph looks like. So we got to start out just a little bit easier. How about just do this? 81 to the 0. What the hell is that? Now that's kind of like that hocus pocus number. It's 1. You know what I mean? It ain't 0. How about this one? How about 0 to the 18? What the hell is that? What the hell is that? Well, this is 0. Don't get confused. All these actually go through that 0 right there. You know what I mean? Whether it's x to the 17, it goes through the 0. 0 is 0. 0 to the whatever is just still 0. You know what I mean? So yeah, and that might trip you out. That tripped me out yesterday. I was like, well, because yeah, something to the 0 is 1, so you just think 0 to the something. Oh, you're like trips you out. But no, if you have 0, but this you actually have something to the 0th power, and it's 1. Okay, moving on. So we know that one. How about 81 to the 1? Well, that sounds like it's just 81. How about this one? 1 to the 18. Well, sounds like that's just 1. Okay, cool. How about 81 squared? Ooh, see, this is where you do this. Just right off the bat, this is real close to 100 squared. You know what I mean? You're going to be way off, but you're actually going to be so in the ballpark that now we just have 10,000. Like, yeah. And it's going to be less. You know what I mean? So guess. All right, so 7,000. 7,532. And then it's fun. Go 81 squared. Oh, no. It's 6,561. So fair enough. You know what I mean? And then you get how numbers work. 81 squared. Well, is that just going to be 8,100? No, hell no. It's going to be 6,000. Anyway. That's not for this video, but we're trying to get there. You know what I mean? First, just absolutely guess. Crank this up to 100, square it. We're in the ballpark. Because now we're going to do this. 2 to the 18. Now, holy Toledo. Now, this is the more fabulous one. This is fabulous. Because, why is it fabulous? Oh, because it's doubles. You know what I mean? Let's say I said 2 to the 2. Well, we know that's 4. 2 to the 3. That's 8. 2 to the 4. You know, it's just 16. It just doubles. Okay. So, we probably can't do this out to 18. But let's do it 2 to the 5. 32. 2 to the 6. 64. 2 to the 7. 128. 2 to the 8. Well, it's basically 125 twice, which is 250. But then plus 3 plus 6. 256. And then 2 to the 9 is kind of like 250 twice, so that's 500, 512. And then the king, 2 to the 10. So always do this. If you've never done this, go all the way up to 2 to the 10. Go 10,000 or 1,024 and be like, hey, guess what? This is approximately just 1,000. So adios the 24. And then what you get is and we'll do this approximation twice, but every 10, you're going to get 3 zeros. But, you know, this is helpful if you're doubling things like if you have a penny and on the first day you double it. You know what I mean? So even just the first day, you're going to double it. Or it doesn't even matter. I forget if it's the second day you double it or the third. But basically, if you have a penny and you go 365 days, you go a full year, how many pennies are you going to have? Well, that's going to be 2 to the 365. And so what would you do? Well, you're going to say, hey, every time there's 10 of these days, I'm going to get 3 extra zeros. The thing's going to increase by a factor of 1,000. Every time I double 10 times, I'm going to, so if I have $1, if I do 10 doubling cycles, I'm going to have $1,000. And if I do 20 doubling cycles, or another 10, I'm going to do 1,000 times 1,000. Guess what? 1 million. And then if I do another 10 doubling cycles, I'm going to have $1 billion. You know, so all you need to do is go to Vegas and double your money 30 times. Alright, catch you on the flip side. We've got to put more time on the clock. Alright, hopefully we're getting somewhere with this. But anyway, so yeah, but the other thing is, look at this. 2 to the 3. you know what I mean? Hell, that's pretty close to 10. You know what I mean? So this gives us a rough estimate. Okay, so every time we do 3 of these, we get 1 0. Well, let's do this one first. Okay, so we do 365. So you're going to have 365 times. For every 365, you're going to have 36 times you're going to get 3 of these zeros. So you're going to get 36 times 3, 18, 9, 10, 108. Yeah, you're going to get 10 to the 108 zeros. So that is the number. You're going to get 1, and then you're going to get 1, 2, 3, 4, all the way 108 of these things. So maybe 10 lines of 10, and then plus 8, you're going to get that many zeros. So yes, 2 to the 365, just real fast, is pretty much 10 to the 108. And that's screaming accurate. It's very accurate. It's 10 to the 108. Maybe it's 10 to the 109. You know what I mean? Because you had this little thing. But this would only do 5. So you're only going to, what's 5 times? See, if you only double it 5 times, you only get 32. You know what I mean? You basically get 1 extra 0. See, you'll get 1 extra 0, but that's it. You know, if you double it 7 times, if this was 367, we could do, well, you got, then you could add 2 extra zeros. But you could probably only add 1 extra 0. You know what I mean? 364, you're definitely going to add 1 extra 0. So let's do this one again. Let's say I just did every 3 times it's going to get an extra 0. But it doesn't. But yeah. So that's where I said, all right, if I go, you know, 2 goes to 4 so 2 to the 1. So you start with 2 on the first day, and then you go to 4, then you go to 3. So we got 3 doubling cycles, and I'm almost 10. Well, almost doesn't count, but 300. I'm just going to say this is 300 days, and then so that's how I got my answer. And I was just like, yeah, this is approximately 10 to the 100. And so that was my first answer to this problem. And then my brother said, oh, well, we'll double out to 10, and then this is like an axiom. Like if 10 doubling cycles is so close to 3 extra zeros, it's so close to a multiple of 1,000. You got $1 and you double it up 10 times in Vegas, you're going to have $1,000. Double it up 20, you're going to have $1 million. It's impossible to double it up that much. But in theory, double it up 30 times, you're going to be a billionaire. Whoa, yeah. There's $1 million, and that's $1 billion. Double it up 40 times, 40 doubling cycles is $1 trillion. 1T. All right, so we learned something about that. Cool. And what the hell did we have? We had 2 to the 18. So let's use both. We're going to use this one, just real bad. It's 6 doubling cycles. We're going to get 6 zeros because this is 10. You know what I mean? And then this one, we're going to get. Well, let's just say it was 20. 2 to the 20. We already did that one. And this is 2 to the 10. And this is 2 to the 20. So you're going to get really close to $1 million, but less. So let's just start with $1 million. Yeah, you're basically going to have $1 million, but then you're going to divide by 2. You're going to have 500,000, and then divide by 2. You're going to have 250,000. All right, so we're pretty close to this. So 2 to the 18, 250,000 final answer. Yeah, and it's 262,144. Okay, now let's do our junk way. We would say this is, you know, you're basically going to get a 0 for every 3 of these, and we're going to get 6 zeros. That's the same thing. So this just shoots us high. This shoots us at $1 million. But we can recognize that this is not 2 to the 20. No. We can recognize that this only gives us 8. It doesn't give us a 0 every time. It gives us, for every one of these zeros, it gives us an 8. So I don't know. You would have to do you. Well, I'm sure there's another way to figure out how to figure out how many halves this would, you know what I mean? How many did we lose? Well, we doubled it 6 times. And we're losing 20% every time. You know what I mean? So you're losing 0.2 every time. So let's see, 1, 2, 3, 4, 5, 6. I don't even know if this even makes sense. 0.2, 0.2, 0.2, 0.2, 0.2, 0.2. So these are the doubling cycles you're losing. 0.2 times 6, and you're losing 1.2 doubling cycles. Maybe that doesn't make any sense, but you would go to 500,000, and then you would go 80% of that. But that's I don't know if that even made any sense to me even. So anyway, don't do that. But yeah, these are just rough estimates of how to do this. All right, so now we're going to go back and we're going to go 81 to the x to the 18. So at least we're understanding if you put a 2 here, you're basically doubling. Well, let's put a 3. Well, let's put a 3 here. So we're going to go 3 to the 18. Well, that's tripling. So let's say you start with $1. 1, 2, 3, 4, 5, 6, 7, 8, and then you start with $1, and then you have $1 on day 1. On day 2, you're going to triple it, so you got 3. On day 3, you're going to have 9. Doesn't that make sense? Isn't this I don't know if that makes sense at all, but yeah, this is tripling. So you're gonna say you have to do this 18 times. You got to go down to 18 and then figure out how much money you have, because you're gonna have 3 to the 18 is 3 times 3 times 3, 18 times. So this is and then this is the bummer. We should have started with 3. So we got to start with 3, and then on day 2 we're going to triple that. So then that's where the confusing part was. So 3 to the 1, 3 to the 2, and we're going to triple this, and this is 3 to the 3. So just right off the bat, we do 2 doubling cycles, and you're basically getting 10. You're adding another 0. So let's do it. If you divide this by 3, if you divide this by 2, you get 9 doubling cycles, and you're going to add a 0 for each of them. Perfect. So this number right here, 3 to the 18, is going to be 1 with 9 zeros. So it's going to be $1 billion. So in kind of final answer, it's going to be just a little bit lower. You know what I mean? But not by much. I would say 400 million. All right, so 3 to the 18. Oh, perfect. It's 387 million. 420, 489. Yep, so we knew this was an overestimate, but it got us there. So that's tripling. How about x to the 18? How about 4 to the 18? Well, we're going to start with 4. 1, 2, 3, 4. We're going to start with 4. Double that, we're going to get 16. Now, this is where it gets crazy, because 16 times 16, 36, 6, 7, 8, 9, and then a 16 all the way across, and we get 6, we get 5, and we get 2. 256. So yeah, so in 3 doubling cycles, we're going to double it, and then quarter it. You know what I mean? So yeah, let's do this. This would be fascinating, because if this was 1,000, hell yeah, we're money. But only 2 to the 10 actually is the only one that actually gets up to a 10 or a 1,000. It's really hard to actually land on one of these that actually makes sense. So let's do this. So every 3 doubling cycles, we're basically going to get 1,000, but then we got to quarter it. Fair enough. And we're going to have 6 of these doubling cycles. Okay, so we're gonna start with the first 1, 2, 3, 4, 5, 6. So all right. So the first one we're gonna do we're gonna multiply by 1,000. So we started with the number 1, I guess. Maybe we didn't. Maybe we started with the number 5. I have no idea. But oh, we gotta put more time on the clock. All right, hell yeah. So So in one doubling, we got 3 doubling cycles, 3 quadrupling cycles. Yeah, these are not doubling cycles. These weren't doubling. These were. So this is a quadrupling cycle. So if you have 3 quadrupling cycles, you'll get 1,000. Okay, so this is a quadrupling cycle. These are each quadrupling cycles. And so yeah, you're basically just going to get 1,000. But this, so multiply by 1 times 1,000, but divide by 4. So you're going to get 250. Alright, but now we're going to multiply by 1,000, 10,000. We're going to put 3 zeros. So we're going to go 1, 2, 3. But then divide this by 4. This is kind of like 24, so it's going to be, this just turns to 6, so it's going to be 60,000. Divided by 4 is 60,000. I just put it right here. So 60,000. Add 3 zeros, 1, 2, 3. But then we got to divide this by 4. Oh, yeah. And then who cares? Just call it 10,000. Well, we'll call it 12,000. Okay, and then we got to add our 3 zeros, and then we got to divide by 4. That's going to be 3. Okay, perfect. So now we're on a roll. Add our 3 zeros, and then we're going to divide by 4. That's just basically 1. This is our last doubling cycle. So we got to add 3 zeros, but then divide by 4, and then you're going to get 250. 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And this is 1, 2, well, 3, 6, 9, 12, 13, 14. 2.5 times 10 to the 14. Final answer. So yeah, just a way to guesstimate. So what the hell is 4 to the 18? It's 6.8 times 10 to the 10. So yeah, that didn't work. So that was not a good way to do that. That didn't work at all. So how about this? Just in two cycles, you're going to get an extra 0, but it's actually going to be way bigger. So let's try to do that. You're going to have 9 zeros, and oh no, this was actually pretty accurate. You know what I mean? As long as this isn't. Oh yeah, because yeah, that's fair enough. I mean, because this is actually really close to 10, and it's on a logarithm scale. So, like, this is closer to 10 than it is to 100, and that's what you're doing. Because if this was 81, then you would actually add 2 zeros. But at 16, you're just going to add 1 zero. So even just right here, you're going to do for every 2 quadrupling cycles, you're going to add a 0. Even though we already said if you did 2 tripling cycles, you're going to add a 0. So it's the same thing, but yeah, we're going to go. So then you're going to have 4 to the 18. There's 9 quadrupling cycles. You're going to add. So you're going to 1 with 9 zeros, and but you know what I mean. This is low ball. This is low ball. So you're not going to add too many more zeros. You're just going to add 1 more. So now you're going to have 1 times 10 to the 10. And it's 6. You're almost going to add 2 extra zeros. So yeah, fair enough. Fair enough. Oh, yeah, that's interesting. Because if you had 10 of these doubling cycles, never mind. I have a hard time. That's almost, you have to know about logarithms to figure out, like, you know, what the hell's the excess and the minimum. But 256. Well, can't we just, well, what's 256 times 4? Oh, and this wasn't. Oh, this is where we were way off. Damn it. This was not 16 times 16. Oh, so yes, we can do this. Okay, but 16 times 16, this was 4 times 4, 4 times 4. This is 8 doubling cycles. See, we called this 4 doubling cycles. Or what the hell did we even call this? Well, let's do this one again. Okay, so we have 4 to the 18. And what's 4 to the 1? Well, that's 1. 4 to the 2, that's 4 times 4, that's 16. 4 to the 3 is 4 times 4 times 4. That's where I got kind of messed up. Well, what's 4 times 4? That's 24. And then 4 is 40, so it's 64. So we got 64. And then 4 to the 4 is 64 times 4. And that's where we get 24, 25, 256. Yeah, so for every 4 of these, And what's 18? And we only have 18 quadrupling cycles. So 18 divided by 4. You're only going to do this 4.5 times. You know, we did it 6 times. So yeah, you were only going to do it 4.5 times. Let's just say you were going to do it 5 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so yeah, 4 is going to be... So it's going to be greater than 1.2 times 10 to the 10. Our number is going to be greater than that. And because of logarithms, like, or you know what I mean, it's not halfway between, because this is 3 times 10 to the 12. But it's not. It's like, so once you actually say, hey, this is closer to 4, so you can use that in your head. How many doubling cycles? Well, there's only 4. You know what I mean? Quadrupling cycles, and I shouldn't say doubling. But anyway, so yeah, so there you get pretty darn close. So anyway, using these approximations. So man, and again, I don't want to make these math videos like friggin' 3 hours long, because my camera burns up and I just can't. So let's just get to it. 81x x to the 18. Now this was the cool thing. Now can we figure out how many solutions there are? Because that was my question. First, well, let's throw in -1, 0. We might throw in -2, and then 1, and then 2. Especially with these things that blow up. All right, what's 81 to the 0? That's 1. What's 1 to the 18? Or no, what's 0 to the 18? Well, that's 0. Okay, and I'm gonna put a box around which number's bigger. Hey, that number's bigger. Now let's go up. What's 81 to the 1? That's 81. What's 1 to the 18? That's 1. Okay, again, this box is bigger. But how about 81 squared? Well, that's very similar to 100 times 100, which is 10,000. Okay, and then 2 to the 18. Well, we already did that. It's basically 2 to the 20. I mean, just approximate 2 to the 20. 2 to the 18 is basically approximately 2 to the 20, and then that's 2 to the 10. Well, we said that's 1,000 plus another 1,000. So yeah, you're already at 1 million. You know what I mean? So this is 1 million. This is bigger. Oh, see, you're gonna have a solution here because you started out with this side being bigger. Now this side's bigger. Okay, fair enough. And the crazy thing is if you throw x is equal 10 to the 18. If you have 1 with wait a minute. 10 to the 1 is 10. 10 to the 2 is 2. Yeah, so yeah, this is 18 zeros. And 18 divided by 3 is 6. So you're going to go 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 3 packets. Alright, so there you go. You're going to have millions, billions, trillions, quadrillions, and then centillions. 1 centillion or whatever. You know what I mean? Just make up a number. But yeah, this is 10 to the 18. This is x is equal to 10 to the 18. So if you throw in this number to the 18 power, now what do we do to this number? Well, we can do this. This is really close to this number to the 20. So this number to the 20, which was saying it's just a multiple of a million. So this is 1,000,000 times. No, I don't think that actually makes sense. Because this is 10 to the 18. If we squared it, you would have 10 to the... Oh, gotta put more time on the clock. Bummer. Alright, holy Toledo. I only have 6 minutes left. And no, we were totally left field. Because you throw in 10 here. Let's throw in 10. Because the answer is 9. So that's one of your solutions. You have another solution in between 1 and 2. So that's a solution. And then even this way, you have another friggin' solution. So well, let's do this way first, and then we'll go that way, see if we have time. So 81 to the 10. Well, what the hell does that even mean? I have no idea. But 10 to the 18, hell yeah, that's 10 to the 18. Perfect. But now we have 81 to the 10. So this is crazy because you're, instead of doubling 2 to the 10, instead of doubling, you know what I mean, you're going 81 times 81. And we're just going to do it. 81 times 81 is, oh, perfect. So for every, so you're almost getting up to 10,000. So if we go 81 to the 1 is 81. 81 squared is 6561, which is approximately 10,000. Okay, so we got 5 of these. So we got 5 of these 10,000s. So yeah, booyah. So you're going to have 1, 2, 3, 4. So this is 4 zeros, and then you're going to have 5 of those. So you're basically going to have 20 zeros. So yeah, this number is going to be 10 to the 20. And then this number is going to be 10 to the 18. Booyah! So there you go. Put a box around that one. This is smaller. You have another friggin' solution. So this wasn't that hard to do. You only had to multiply it twice to figure out how many. So that's like the, not a doubling cycle, not a quadrupling cycle. It's a 1 to the 81 cycle. And then, yeah, just instantly, you do it one time, figure out, get it to the closest tens place, and you can actually estimate this. All right, let's go this way. So 81 to the negative 1. What the hell is that? Isn't that just 1 over 81? Yes, holy. And that's basically 1 over 100. So yeah, 0.01. So that's what that is, because we go 1, 2. 1, 2. Okay, and then negative 1 to the 18. Booyah, it's just 1 to the 18. It's just 1. Okay, hell yeah, so this is bigger. Hell yeah, so we found our other solution. We don't have to go on anymore with this problem. We learned what this is, but can we graph it? You know what I mean? Can you take this and say, hey, this is just like whoop-de-scoop-de, and then we're going way the hell up. And let's say this is 9 over here, because we're going to have to cross paths. And then this, like, what if you take this to just a huge number negative? You know what I mean? It's negative, so you're going to go 81 to the negative 10. Does that even make sense? Nope, I think this is the only one I can wrap my brain around. Because isn't 81 to the negative, isn't that just 1 over 81 to the 10? Yeah, so it's just a huge lead. So this number is just grossly huge. And then divide by 1, so it's basically 0. You know what I mean? So this thing starting at 0, coming in, and even at negative 1. So here's your positive 1 and 1 right there. So that this is 1, and this is just like a huge number. Holy Toledo, we got 2 minutes. So we're coming in here, but yes, it doesn't go through, if this is negative 1, it doesn't go through negative 1. This does, because it's a mirror image. But this just stays hella low. You know, just barely, but then it crosses. It does cross. This does get, because at 0, this is still 0, but this is 1. So this crosses right here. Hell yeah. And then at 1, this is 81. At 1, this side is 1. But at 2, so we're just going to put a fictitious 2 here. This side is 1 million. This side is, so this one is 1 million. So right there is 1 million. Okay, but then this side is only 10,000. So this side at 2, when it gets to 2, it's only like right here. So yeah, booyah, you crossed here, but then you crossed there. But then check this out. Man, do we have time to do this? Yeah, you finish up. You got 1 minute and 30 seconds. Okay, but then you get up to 9, and this line goes hella screaming. So we're just going to do this. This line goes, so if this is 9, booyah. This just goes, whoop, whoop. No, this is 10. This is 10. So they're going to cross at 9, and we're going to say this is 10, and we're going to say this is 10 to the 18, where this is 10 to the 20, and they're going to cross right at 10 to the 9. There you go. That's your crossing route. All right, Peyton Manning. Hell yeah. So that's the graph. And then they just diverge. This thing goes steep as crap. This thing is the thing that just blows up straight. If you can go to Vegas, start doubling, tripling, 81 in your money. Holy Toledo. You be rich. But even if you can just do a hell of a, x squared. If you can x square your money, x to the 18, you got it too. 10 seconds, but we did it. See how there's like, hell yeah. And then, yeah, this thing crosses paths 3 times. There's 3 solutions. 3 solutions.